Okay, so here I am in Desmos, and so I want to show you how e to the x can be rewritten as this infinite polynomial 1 plus x squared over 2 plus x cubed over 6 and so forth. Here's that formula written in summation notation, and if you're not familiar with summation notation, don't worry about it too much. But this formula, you'll see this in calculus, and you'll learn all about summation notation. But this formula is that infinite polynomial that we talked about at the end of section 3.8. And so what I want you to do is take a look at this. It's really pretty cool. So the green curve here is the graph of f of x equals e to the x. The red curve is the graph of this infinite polynomial, and right now p is 0, so it only has one term. But if I let the number of terms in this infinite, or if I let the number of terms in this polynomial increase, then what you're going to see is that this red curve is going to start to look more and more like the green one. So I'm going to press play so you can watch this happen. So this is if I have if I just have one term, 2 terms, 3, 4, 5, 6, 7 terms, and so forth. And, after 10 terms or whatever we're at now, it's like on the left-hand side, it's pretty near identical. They're pretty nearly identical. And as this thing continues to increase, it starts to look more and more like the green function. So I think that's pretty cool. So there's kind of some, not proof, I guess, but that hopefully convinces you that this thing and this thing, if you let p go to infinity, then this thing and this thing are going to be really the same thing. We can say the same thing about the cosine and sine functions, right? So here's the infinite polynomial for the cosine function. So again, the cosine function's in green and the approximating polynomial's in red. If we just have one term, then it's not a very good approximation. But if we let this thing have more and more terms, then you see that it turns into the cosine function. So if you let p go to infinity, you're going to end up with the cosine function, which is a pretty cool thing. It gets harder for Desmos to do the calculations the more terms you get. But it's pretty cool. And same thing with the sine function, right? So again, sine function is in green. This polynomial thing is in red. And it's going to get, if you let the number of terms increase, it gets closer and closer and closer. Okay. So pretty cool. You'll learn how to do these kinds of approximations in calculus. But yeah, for now, hopefully that convinces you that e to the x is really the same thing as this infinite polynomial, cosine x is really the same thing as this infinite polynomial, and sine x is really the same thing as this infinite polynomial. That should tell you a little bit about why we think polynomials are so important in mathematics. And in fact, that's the topic of chapter 4, right? So the next chapter that we are going to tackle, the next topic that we're going to tackle in this class is all about polynomials, because you can use them to approximate all kinds of stuff. But here's why this is interesting. So a couple reasons. In the first place, we said in the past that certain values of the trig functions we can memorize, like we know that sine of 60 degrees, for example, is root 3 over 2. But then other values like 63 degrees, like how do we find that out? And I just said, well, just use your calculator, right? And that may not have been very satisfying to you, because you may be thinking, well, yeah, that's fine, but what's my calculator doing? How is my calculator calculating sine of 63 degrees? Well, this is what your calculator is doing. It's using this function. And it's plugging in 63 degrees. First, it has to change it to radians, right? But then it plugs in the radians into this function. and it does it to a certain number of decimal places. I'm not exactly sure. Probably that depends on the calculator. But the more terms you add, the more accurate your answer is going to be. But I think by the time you get within, maybe 10 terms, you're pretty darn accurate. So that's the first. That's the answer to one question that you may have had. Like, what is my calculator doing to calculate these values? Well, it's actually plugging the value into this infinite polynomial. That's what it's doing. The other thing is that it shows us just how related the exponential function is to the sine and cosine function. And in fact, there's this really famous formula called Euler's formula that connects these three concepts together. So I have a YouTube video that so here's a link to that. I'm gonna post the video in our Canvas course as well so that you can see it. But I would highly encourage you to watch it. It's really cool, all about Euler's formula and how these three things are really really closely interconnected. So that's all I wanted to say about that. And we'll see you in the next section.